So this is test 6 review. There are 12 questions in this review assignment. So let's read the first question. 20 different statistics students are randomly selected. For each of them, their body temperature in centigrade is measured and their head circumference in centimeter is measured. For this sample of pure data, what does R represent and what does rho represent? So R is actually, it's a correlation number, which is for the sample, and rho is for the population. So let's find out that information here. R is a statistics that represent the proportion of the variation. R is a statistic that represents the value of the linear correlation coefficient computed from the pure sample data, and rho is the parameter that represents the proportion of the variation in head circumference that can be explained by variation in body temperature. R is a statistic that represents the value of linear correlation coefficient computed from the pure sample data, and rho is the parameter that represents the value of the linear correlation coefficient that would be computed by using all of the pure data in the population of all statistics students. So this is the right choice. R for the sample and rho for the population. Without doing any research or calculation, estimate the value of R. Select the correct choice below and fill in the answer box to complete your choice. The value of R is estimated to be, so where is that? 20 different statistics students are randomly selected. For each of them, their body temperature is measured and their head circumference is measured. So look at here. R represents the correlation coefficient between the body temperature and head circumference. I don't see there is any correlation. Your body temperature could be different versus your head circumference. So the value of R is supposed to be 0 because there is no correlation. The value of R is estimated to be, because it is likely that there is no correlation. Okay, so that is the first one, and then that's supposed to be 0. Finally, does R change if body temperature are converted to Fahrenheit and degree? Correlation coefficient, that correlation number doesn't change even you change the units of the data we're using. So the value of R doesn't change because R is not affected by relationships that are not linear. No, the value of R does not change because R is not affected by converting all the values of variable to a different scale. Yes, so this is the right option. Okay, so that's one of the requirement. The value of R doesn't change even you change the units. Find match these values of R with the accompanying scatter plots. So these are the value of R, so we need to match it. Scatter plot 1, R equal. So first of all, you have to look at the plot here. So as you can look at here, the graph here, you can see that it's somehow linear and it's going down. You can just draw a straight line, and so the value of R should be negative here. Here the value of R should be positive. Here the value of R should be positive because it's growing. Here it's negative and it's more straight line, so it should be very, very close to -1. And this one, it's going down, but not perfectly down, so it would be negative but far from -1. Okay, so I can say for sure that scatter plot number 4 has -1, so it's supposed to be -1. Okay, and scatter plot number 1, it's supposed to be close to -1. So look at the options we have given: -0.4, -0.7, -1 is already gone, and there are two different options you have available, -0.4 and -0.7. so this one is negative and this one is also negative. So by looking these two, it looks like more linear. It's more close to a straight line. If you draw a straight line here, there are data, they are far from the straight line going down. So it's the correlation coefficient for the number 1 supposed to be, you know, more close to -1, which is -0.7. so this is what I'm going to choose. And for the second one, where is that? And for the fifth one, it is also negative, so the leftover negative is -0.44. And now we have two leftover, and both of them are positive. 0.4 and 0.7. So look at the scatter plotter, scatter plot number 2 and 3. By looking 2 and 3, as you can see here, both of them are going up. So the value of r should be positive, but it's more linear. Okay, so the value of r is supposed to be more close to 1. So number 3 is more close to n, which is 0.79, and number 2 is also positive but less than 0.79. So that's how you can find out your value of r by looking the scatter plot. Okay, use the given data set to complete part A through C. Use alpha equal to 0.05. So this is the data we have given. Click here to view table of critical values for the correlation coefficient. So you can either use the table here or you can use the Statcrunch. So first of all, we would like to choose which one is the right scatter plot for this data. So just click it here, open in Statcrunch, and when you do that, you can just go to the graph and go to scatter plot. And as you can see here, the x value goes to the x value, y value goes to the y value, and just hit compute, and it's going to give you the scatter plot. So based on this, the number, this one is the right one. Okay, now find the linear correlation coefficient r. So you can find the linear coefficient r. I'm going to close this. For finding that, you can go to the stat and regression. That will, and then after going to the simple linear, it will give you so many so much information than the linear correlation coefficient. So choose x for the x variable, y for the y variable, and then just hit compute. This table is going to give you so much, like correlation coefficient, which is 0.8150. If you round it to the 3 decimal place, it's a 0.815. Now, using the linear correlation coefficient found in the previous step, determine whether there is a sufficient evidence to support the claim of a linear correlation between the two variables. As you can see here, it's more close to 1, so it's a sufficient. But how do you find that? Here the alpha is 0.05. We can see, we can look at this table and you can see that there is a p-value. Always find the p-value by going to the slope row. Here, this row, this is your p-value, which is 0.002, which is compared with the alpha value. P-value is less than alpha value. So whenever p-value is less than alpha, it supports the evidence. So let me just show you that what I'm talking here from this section. Where is that? This one. If p-value is less than alpha, supports the claim. So there is a sufficient evidence to support the claim of a linear correlation between the two variables. So this is our option. Now, identify the feature of the data that would be missed if part B was completed without constructing the scatter plot. Choose the correct answer below. Okay, look at here. If we do not have this scatter plot, we were assuming that it's a more correlated, they are the patterns should be straight line, but because of this we can say that, hey, it's not a straight line. It's there is a correlation for sure, but it's not a straight line. So the scatter plot reveals a distinct pattern that is not a straight line pattern. So this is what we're going to find from this scatter pattern. So let's check the answer, and that's correct. Let's go to next problem one more time. Very, very similar question. This is question number 4. Same thing. So I'm going to skip this question. It's a repetition. Just do as we did previous question. Number 5, listed below are numbers of internet users per 100 people and number of scientific award winner per 10 million people. Internet user and award winners for different countries. Construct a scatter plot, find the value of the linear correlation coefficient r, and then find the p-value of r. Determine whether there is a sufficient evidence to support a claim of a linear correlation between the two variables. Use a significance level of alpha equal 0.05. This problem is also very similar to the previous problem. First of all, open your data in Statcrunch, and this is the data. Now you want to plot the graph. So let's go to the graph, choose a scatter plot, choose your X variable, which is internet user, Y variable, which is award winner, and just hit compute. It's going to give you the scatter plot, as you can see here. Now compare the scatter plot we got here with the given scatter plot. So as you can see here, this is very close to the first one. So that is our answer. Now the linear correlation coefficient is, we can find out the linear correlation coefficient by going to by using the Statcrunch. Go to the regression, simple linear, choose X variable, Y variable, and just hit compute. It's going to give you the correlation coefficient, which is 0.828, because you have to round it to the 3 decimal place. So it's a 0.828. Now for this correlation topic, the null hypothesis is always equal to 0. The null hypothesis means population correlation, and alternate of that is not equal to 0. Now from the very same table, we can find out the test statistic by going to the second row here in this table, which is slope. This value is the test statistics, which is 2.95 if you round it to the 2 decimal place, and p-value is coming from here, which is 0.042. So 2.95, 2.95, and 0.042. If I just go back and check one more time, 0.042. So as you can see here, the p-value, and now compare the p-value with the alpha. Alpha is 0.05, p-value is 0.04. So that means we can use the very same thing. P-value is less than alpha supports the claim of the linear correlation. So because the p-value of a linear correlation coefficient is less than alpha, there is sufficient evidence to support the claim that there is a linear correlation between internet user and scientific award winner. Okay, so that's our answer. So next problem. Next. Okay, which of the following is not a property of the linear correlation coefficient R? The value of R is not affected by choice of X or Y. This is correct. The value of R is always between -1 and 1 inclusive. That is correct. The linear correlation coefficient R is robust. That is, a single outlier will not affect the value of R. That is not correct. The value of R measures the strength of a linear relationship. So this is not correct. So let's check the answer and go to next problem. Okay, so this is a regression problem using the weights and highway fuel consumption amount miles per gallon of the 48 cars listed in the accompanying data set. One gets this regression equation. So remember, this is a regression equation for the sample where X represents weight, complete A to D. So first of all, this is the relation between weight, using the weights in pound, and highway fuel consumption. So Y cap means it's a highway fuel consumption. What does the symbol Y cap represents? Y hat or Y cap, whatever. Y hat represents the predicted value of the highway fuel consumption. Y cap represents the predicted value of weight. It's a fuel consumption, so there are two options. Y hat represents the actual value of the highway fuel consumption. So this is predicted value of highway fuel consumption. It's not actual. So that's whenever you see the Y cap, that's the predicted value. What are the specific values of the slope and y-intercept of the regression line? So this is the regression line. Slope is a number in front of x, which is in this case negative 0.00749, and y-intercept is 58.9. So the slope is negative 0.00749 and y-intercept is 58.9. What is the predictor variable? The predictor variable is this x. So where are x? There are two options. The predictor variable is highway fuel consumption. That's not highway fuel consumption, that's the weight. So the predictor variable is weight, which is represented by x. Assuming that there is a significant linear correlation between weight and highway fuel consumption, what is the best um, predicted value for a car that weighs 3004 pounds? So now we can use this relation, and then value of x is given, which is 3004. Just plug x equal 3004 and do the calculation. So I'm going to use a calculator here. So let's say 3004 times this slope. So slope is negative 0.00749 times 3004, hit enter, plus there is a intercept 58.9, so you have to just add that one, and that is our prediction. So the best predicted value of highway fuel consumption of a car that weight 3004 pound is 36.4 miles per gallon. 36.4 if you round it to the one decimal place. One more time, sorry, it's not the, it's 36.4. Okay, that's correct. Let's go to the next problem. What is the relationship between the linear correlation coefficient R and then slope B1? So the linear correlation coefficient and slope, they have the same sign. If the correlation coefficient increases, the slope increases. So the value of R will always be smaller than, the value of R will always have the same sign as the value of B1. So that's the right answer. Suppose IQ scores were obtained for 20 randomly selected sets of siblings. So the 20 pairs of measurement yields, this is the average for that sample for the X, and this is the average for sample Y. This is the correlation coefficient, and p-value is 0.0, and this is the regression relation. It's a best fit. It's a linear equation where X represents the IQ score of the older child and Y represents the younger child. Find the best predicted value of Y hat given that the older child has an IQ of 109. So you want to find, and by using this equation you want to find out if the value of X is 109, what is the value of Y hat. So as you can see here, you can use calculator. It's a very simple calculation. Just plug the value of X, which is 109. 109 times 0.94 times it plus 9.17. By using this equation, by using this straight line equation, we can predict the best predicted value for Y cap is 111.63. 111.63. That's our answer. Let's go to the next problem. Okay, we have data. Based on this data, we would like to find out this regression, this line linear equation. Use the given data to find the equation of regression line. That's called equation of regression line. Always just go here, open in Statcrunch, and by doing that you can go to stat regression and simple linear, very same thing we used before. The X variable is X, Y variable is Y, and just hit compute. It will give you everything you need. So this is the relation we are looking for, this one. Y equal 2.60 1.1. So Y cap, instead of Y cap there is a Y. So just copy this value, 2.2 decimal place, 2.60, 2.60, that's the Y-intercept. And then for the slope is 1.1. 1.1. And if we would like to graph it, it's easy. Go to the very same scatter plot. Where is that? I'm going to just make it small and go here, graph, scatter plot, X is X, Y is Y, compute, and that will give us the graph. And by looking the given option here, this is looks like the right one. Identify a characteristic of the data that is ignored by the regression line. Look at here, this is supposed to be line, but here as a graph it's not a line, so there is no trend in the data. The data has a pattern that is not a straight line, so this is right, this data has a pattern that is not a straight line. Okay, let's go to next problem. Again, we have given data, we need to find out regression line, and then we have to predict based on that regression line, and then we have to find out our conclusion. We're going to repeat the very same thing. I'm going to copy this, open in Statcrunch, and then go to stat regression simple linear, and the x value is, what is the x value? So remember, you have to be very careful. X means letting the chest size be the independent variable. So chest size is x and weight is our y. So by hitting that compute, we are going to find out this what is that, this relation, as you can see here. So weight in pound is equal to, this is our regression line. So this is a value we are going to copy, but we need to just round it to the one decimal place. So negative 172.6, negative 172.6, that's the y-intercept, and the slope is 11.1. And now, what is the best predicted weight of a beer with a chest size of 51 inch? By the way, so that the data shows chest size and the weight of the several beers. So this is our model, this is our regression line. Based on this regression line, what is the best predicted weight if the chest size is 51? So just use x equal 51, multiply it by 11.1, and then add negative 172.6. that will give you the weight. So we can use our calculator here. So 51 times 11.1, hit enter, and minus 172.6, that is 393.5. that's the weight, 393.5. Is the result close to the actual weight of 352? This is not close. This result is not very close to the actual weight of the beer. So this is not very close, because the actual weight was 352, it's 393. The last problem, this is very similar to the previous problem. There is a regression line you need to find out. So the answer is already given. Just copy, open in Statcrunch, and then choose regression simple linear, president supposed to be x, opponent supposed to be y, compute it, and it gives you opponent equal 207.0154, round it to the nearest integer, which is 207, and then the slope is 0.157, as you can see here. And now using this, the best predicted height of an opponent, given that president had height 188 centimeters, so just put 188 here, multiply with negative 0.157. so I'm going to use this. So 188 times negative 0.157, hit enter, plus 207, that will give you 177. If you round it to the one decimal place, it should be 177 point, round to one decimal place as needed, 177 point, it's supposed to be 5, but why it's 178? That's supposed to be, round to the one decimal place, it's supposed to be 178.5, but they're rounding it to nearest what is that, nearest centimeter. It's supposed to be 177.5 if you round to the one decimal place. Okay, this is not correct. It's supposed to be 177.5. And finally, how close is the result to the actual opponent height of 175? 175 is within 5 centimeter of actual weight. So here this is supposed to be 177.5.